Welcome back to the channel. In today's video, we're going to do some more factoring with polynomials. We are almost done with this chapter. The only few lessons we have left are kind of some of the special situations, and that's what we're going to look at today. We're going to look at factoring polynomials again, except now we're going to look at some of the special situations. Today we're going to look at the difference of two squares. Now, if you're a student in my class, you're like, wait a second, I think I've heard that before. We actually did the difference of two squares when we were talking about multiplying polynomials. For example, on these two questions here at the top, this is what we've done earlier in class. We actually did this before the coronavirus break, and this is one of the things we reviewed in my videos once we actually got on break, how a special situation happens whenever the first parentheses and the second parentheses are almost identical, right? You can see in both of these, the questions are almost exactly the same as far as the first parentheses compared to the second parentheses. The only difference is one has a plus sign and one has a minus sign. And so for the kids who did this with me in class, they would either distribute or they would do FOIL, whatever method they like to work it out in. And what ends up happening, if you work it out, and this is the long way to do it because eventually you'll get a shortcut, but if you don't know that there's a shortcut to this and you work it out the long way, this is me distributing, or it's actually the same thing as FOIL. When you work it out, I ask my kids, hey, what was kind of special about this one, right? And almost everybody immediately recognizes, oh, your two terms in the middle, the OI, the O and the I in your FOIL, right? F-O-I-L, in the OI, the O and the I spot, they cancel each other out, right? Negative 3m plus 3m, that combines to equal 0. So you don't have any more terms in the middle. And instead of being a trinomial, all of these answers were always binomials, right? The O and the I will always cancel themselves out whenever your question looks like this. It's the exact same thing in both parentheses, with the only exception being one's a plus sign and one's a minus sign. And it doesn't have to be like the plus has to be in this one and the minus has to be in this one. It could be flip-flopped where the minus sign is in this parentheses and the plus sign is in this one. So if you know that shortcut and you know that's the pattern, anytime the parentheses are exactly the same, all you really have to do is the F, first times first, 4W times 4W, and you have to do the L, the last thing in each parentheses, times the last piece in the other parentheses, and you can get the answer in about 10 seconds, right? You don't have to do the two terms in the middle, the O and the I, because you know they're always going to cancel out. They're always going to equal 0. Now, this is a special situation because it only happens in questions like this, where the two parentheses are perfectly identical with only one exception. One has a plus sign and one has a minus sign. But like the terms are the same, 4W and 4W, 5 and 5. M and M, 3 and 3. It just happens that one has a plus and one has a minus. So that's what we did earlier in this chapter. Today we're going to do the reverse of this, right? We're going to start out with the answer, and we need to come up with the two parentheses, the question that gave us this as a result. So that's why this is called factoring instead of multiplying. This is factoring it. We're going to go the opposite of what we did whenever we worked the question out like this. Now we're starting with the answer, and we need to come up with the two parentheses that would give us this result when we multiply them together. So they call this the difference of two squares because they mean square like perfect square. They don't mean square like, oh, I'm going to draw the shape of a square, right? When they say square, they mean numbers like this, right? 1 times 1, 2 times 2, 3 times 3, 4 times 4. I could go on and on and on to infinity and beyond, right? I could go as long as I needed to. These are the most common perfect squares that you see in math classes, and that's probably about as high as they would make you go. Whoops, I forgot 196. So as long as you see a perfect square, when they say squares, difference of two squares, that's what I mean. Two perfect squares. Numbers that if you did the square root, it would be the answer would be a whole number, right? These all have square roots that are regular numbers. They don't have decimals. They don't have fractions. All of these have a square root that is another whole number. So that's what they mean when they say squares. And so if you notice that you have two perfect squares, right? Like this is 1 technically, right? All you have to do is do the square root of each one, right? How did they get W squared? Well, it had to be W times W. How did they get 81? What's the square root of 81? 9, right? And I know the signs have to be complete opposites from what we practiced up at the beginning, or the only way to get negative 81 is to have one be positive and one be negative, right? There it is, super easy. All I have to do is recognize, hey, do I know the square root of 100? Do I know the square root of 9? Do I know the square root of w squared? Do I know the square root of 81? And then just make sure one of your signs is a plus and one of them is a minus. Another way to think of it, you know, the other day I was really detailed in making you guys think the little brain teaser ones, right? What two numbers would multiply to equal negative 81? But we don't have a middle term here, right? And this one is going to add up to 0, right? What two numbers would multiply together to equal negative 81 that would add up to equal 0? And that's another way to think about it. Positive 9 and negative 9 would multiply together to equal 81 and would add up to equal 0 because they're complete opposites. So these are always really easy to recognize because, look, they are binomials. Binomials. There's only two terms. All the other ones that we would do and all the other questions we've done so far in this class, they've always been trinomials. So there's always been three terms, right? Something like this. Right? And so this is a really obvious situation to recognize because it's only going to be two terms, right? And because it's a difference, there's always a minus sign in here. So I'm sorry, I'm getting off track. Let's do the next one. Do we know the square root of 100? Sure. That's got to be 10 times 10. Do I know the square root of 9w squared? Sure. What's the square root of 9? 3. And then to get w squared, it has to be 3w times 3w. And then one is a plus sign, one is a minus sign. I like to put the plus in the first parentheses and the minus in the second parentheses. You don't have to make it that way. You can have the minus sign here and the plus sign there. It's not really a big deal, right? You see how these don't really take a lot of mental math? I don't really even need to do this little brain teaser question, what two numbers multiply to equal whatever. I can just say, hey, do I know the square root of 100? Yep. Do I know the square root of 3w squared? Yep. And boom, I got it. 10 seconds or less. These questions are actually pretty easy and pretty quick once you get the hang of them. Okay, I kind of was all over the place there with my introduction, so let's actually practice what will these questions look like in an assignment, in a book. Let's get a little bit more down to the nuts and bolts here. Here's three example questions. Special products, difference of two perfect squares, right? Difference means there's a subtraction sign in all of these. If it was an adding sign, it would not be possible to do it the way that we're doing it. So it has to have this subtracting sign in between it. Okay, do a quick double check. Is this number a perfect square? Or is this term a perfect square, actually? Do I know the square root of 36? Yes. Do I know the square root of 49? Yes. So can I do this one in my head in about 5 seconds? Of course I can. What's the square root of 36? That's got to be 6 and 6. How do you get y squared? You do y times y. Okay, for the second term, the 49, how do I get a square, what's the square root of 49? 7 and 7. How do I get x squared? I do x times x, and then the only thing I need is to put a plus sign in one parentheses, a minus sign in the other. Done, right? What does that take, 15 seconds? Maybe, not really that bad. Next question, same thing. Is this a perfect square? Of course it is. What number times itself equals 144? That's got to be 12 times 12. Right here, I made the exponent a little bit harder, but that's all right. Do we know the square root of 121? I hope we do. That's 11 times 11. You know what? Let me put my plus sign and my minus sign in there already. Now, what do I do for this? W to the 6th. How do I get w to the 6th? It's got to be 3 and 3, right? For the exponents, you just cut them in half, 3 and 3. You don't actually do the square root of the exponents. You do the square root of the coefficients, right, the big numbers, but if you have an exponent, you just cut it in half, 3 and 3. So like if this was an 8, we would have had w to the 4th and w to the 4th. If this was a 12, we would have had 6 and 6. The exponents have to be even numbers, right? You would never see a question like this where it was w to the 5th or w to the 3rd or w to the... Any type of odd number is not going to work for these questions, right? Because it has to be the exact same. You have to be able to split the exponent in half perfectly. Okay, we've got one more on this board. I'll go ahead and pause the video, or you can pause the video real fast, see if you can do it in your head, or if you want to work it out on paper, you can. Okay, hopefully you've had a chance to try it in your head. Do we know the square root of 900? Sure we do. That's 30 times 30. And then how do I get x squared? I do x times x. I'm going to go ahead and put my plus sign here and my minus sign there. And then for my second term, 81. Do I know the square root of 81? I believe that's 9. And then what about y to the fourth? How do you get y to the fourth? Well, you've got to do y squared and y squared, right? You just cut it in half. When this is a 4, you just do 2 and 2. You just put half of them in one parentheses, half of them in the other parentheses. See, these are pretty easy. You don't need a calculator. There's no real stress that's being put on your head as far as, you know, calculating what multiplies together and what adds up. There's no combinations. You really have to guess and check. All you have to do is just know square roots in your head, and you're going to be okay. Okay, now what if it's an equation, right? What happens if all of a sudden they make it equal something? Okay, you can do it the same way we have. There's actually 2 ways to do number 4. But if you want to follow the method that we've been learning in this lesson, if I was going to do number 4, I could say, all right, can I factor that? Is that a difference of 2 squares? Are those perfect squares? Yeah, it is, right? X squared would be x times x. 4 is going to be a number that I know the square root of. The square root of 4 is 2. So I can do 2 in one parentheses, negative 2 in the other parentheses, and then I can do that zero product property that we've talked about all chapter, right? I have a multiplying statement. My final answer to a multiplying question is 0. The only way you can get the final answer of 0 in a multiplying problem is to have one of your factors, one of the parentheses has to equal 0. So what number would I substitute right there to make this parentheses equal 0? That would be negative 2. What number would I put in this parentheses to make this one equal 0? Positive 2. All right, so there are 2 answers. X could equal 2 or negative 2. If you want to be a cool cat, you can write it like this, positive and negative 2. That's kind of the fancy way to write it. Actually, let me do that over again. You could say this, x equals positive and negative 2. If you want to be a cool cat and kitten, you can write it like that. And so if they make it an equation, that's all you have to do. You just have to do that zero product property. Now, you heard me say there was actually 2 ways to do this question. You could have actually not even done the special little trick for this one. You could have just said, hey, wait, couldn't you just do plus 4 on both sides, like we learned way back in like the first quarter, and then say, hey, what number squared equals 4? And so you could. There are 2 numbers that have a square root of 4, though, right? The opposite of squared is square root, so you could do square root here and square root here. 2 and negative 2, same thing. That's just a different way to do it. So there's number 4, 2 different ways to do it. I honestly don't care which method you pick, as long as you can get an answer and you are confident. It doesn't matter to me which method you take. Okay, now number 5, I tried to make it a little bit more confusing. Could I do this one with like a short, could I just divide by 9 on both sides? Not really, because 100 doesn't go into 9. But could I make number 5 look like number 4? Could I make it equal 0, right? Could I do minus 100 on both sides and clear out this entire right-hand side to make it equal 0? Look at how much nicer this question is when I write it like this, right? 100 minus 100 equals 0. Whatever I do on one side, I have to do the same thing on the other side. I cannot subtract 100 from this because this is x squared and this is just a plain old number. So look at this statement. Isn't this a difference of 2 squares now? Right? Is this a perfect square? Yes. Is this a perfect square? Yes. Can I say, okay, what's the square root of 9x squared? The square root right here is 3x and 3x, right? Do I know the square root of 100? I hope so. That's 10. Whoops, my 10 doesn't look very good. And 10, make one a plus, make one a minus. And now I'm doing the exact same thing I had up here, the zero product property. Now this is a little bit more complicated, but I can still do it. What number would I put right here to make this parentheses equal 0? Oh, that's pretty hard to do in my head, especially if I'm only an 8th grader who hasn't really got a lot of practice with this. So if I can't figure it out in my head, like this one, it was super easy. You put negative 2, you put positive 2. If you can't do it in your head, just take each parentheses and make it equal 0 and then work it out, right? For this one, we would do minus 10 on both sides, 3 times something equals negative 10. And then you divide by negative 3, and you get this, negative 10 over 3, which is obviously something you could write as negative 3 1/3. And if I'm being honest with you guys, the other answer is always going to be the opposite. It's always going to be like this, positive 2 and negative 2, or positive 4 and negative 4, positive 7 and negative 7, positive 1/2 and negative 1/2. So if you get one answer, you know the other answer is just going to be the positive version of that, right? So as soon as we got negative 10 over 3, we know the other one's going to be positive 10 over 3. It's always going to be the same number, just the complete opposite, right? Your two answers have to be opposites on these because your parentheses are exactly the same. So there you go. Those are about the hardest ones they can give you. All right, and honestly, if I'm being straight up with everybody, that is really the only thing in algebra, anyway, that you'll really need to know. Now, if you just want a little brain teaser, a little mental math trick, I'm about to show you something that, if I'm being honest with you, I've never really used this a lot in my life. I probably should have, but I haven't used this strategy as much. You can use the strategy of difference of two squares to actually help you do mental math questions really, really quickly. So, for example, if you were on an academic team, a quiz bowl, if you're at a math contest, you were in a situation where you didn't have a calculator, you were forced to do something really quickly in your head, and you had to be really, really fast, you can use this difference of two squares to do arithmetic questions in your head really quickly, right? Difference of two squares. For example, on number 6, do I know 44 squared in my head? No. Do I know 42 squared in my head? No. If you ask me, hey, work this one out in your head, could I do it? No. What would I probably have to do? 99% of the people in this world would have to whip out their phone, get their calculator, and they would have to do it on their calculator on their phone, right? Or they would have to work it out on a piece of paper. There's actually a shortcut to do this. Isn't this a difference of two numbers that are squared? Of course it is. And so our book shows us this little mental math trick you could use. Isn't this the same thing as what we have been doing, right? Couldn't I write this as 44 plus 42 and 44 minus 42? Isn't that the format we have been using on all of these, right? We just take the two numbers, 44 and 42, and you put one with a plus sign and one with a minus sign in a parentheses. Now, is everyone capable of doing all this in your head? Of course you are. Everyone who's watching this video can do 44 plus 42 in your head. If you can't, oh my goodness, something is wrong, right? Are we all capable of doing 44 minus 42 in our head? Of course we are. That's 2. Can we all do 86 times 2 in our head? Yeah, we should be able to, right? Hopefully I can. 172, is that right? So you can see how we took a question that looks very difficult, something that there's no way, right? Here's what most people would have to do. Most people would have to take out their calculator and say, okay, 44, and if you knew how to use the exponent button, you could say, okay, 44 squared minus 42 squared, and then you could get your answer, boom, 172. Right? Look, I got it in my head. I didn't need to touch the calculator. Let's do a couple more of those. This is actually something I wish I would have known when I was younger because it would have helped a lot in math contests or academic team. This isn't really a skill that you'll see a lot. 64 minus 36, 64 squared minus 36 squared. That's way too hard for me to do in my head. But what can I do? Since they're both being subtracted and since they're both squared, I can do the difference of two squares, 64 and 64, put one with a plus 36, put one with a minus 36, right? Now, is this something we should be able to do in our head? I hope so. 64 plus 36, that's 100. 64 minus 36, oh, geez, that's 28. Can we all do 28 times 100 in our head? Yeah, that's 2,800, right? It took me 30 seconds to get that answer. That's pretty cool. One more, 19 squared minus 17 squared. Okay, so I'm going to do 19 at the beginning of both parentheses. I'm going to do one with a plus sign, one with a minus sign. I'm going to put 17 in my other parentheses. 19 plus 17, we're all capable of doing that. 19 plus 17 is 36. 19 minus 17 is 2. Do we know 36 times 2? I hope so. 72. So that's kind of just a little neat mental math trick. It's not really mental math because I'm working them out, but it's kind of a trick you can use when you don't have a calculator or whenever you're forced to do something in your head and you're in a hurry, you're in a contest, you're on a quiz bowl, you're really trying to get it done quickly. So anyway, for people that are in my algebra class, I'm going to wrap the video up. I'm going to give you some questions like this, like these three, and for the ones that we practiced on the previous boards. Hopefully these are going to be pretty easy. If you're not in my math class and you're just looking for a chance to practice this, you can go to this website, kudasoftware.com/free.html. On the right-hand side, they have a section for polynomials. And there is a specific set of questions called factoring special cases. Factoring special cases. Now, if you open up that PDF assignment, there's going to be like 22 problems on there. And some of the problems we haven't covered yet. Those are going to be for the next video I make on Monday. But you can do all of the questions on that assignment that are binomials, right, where it's only 2 terms. If you see 3 terms in the question, don't worry about it. Just skip it. We'll do those in the next video on Monday. So thanks again for watching. Hope everyone's staying safe out there and enjoying themselves. I will be back on Monday with another video. Thanks so much.